Hi everyone, today's topic is ionization energy. Let us see the definition of ionization energy. Minimum amount of energy required to remove the most loosely bound electron of an isolated neutral gaseous atom or molecule is called ionization energy. This is the first transition series element. The trend of ionization energy in d block element of first series is this. According to journal trend, ionization energy increase from left to right, but in first transition series the trend is not regular. In this trend, the ionization energy does not depend on one factor. Let us see the example of chromium. Configuration of chromium is 3d5 4s1. This is half filled s electrons. Chromium can easily lose one electron and gets stable configuration. Chromium remove this electron and gets stable configuration. The stable configuration of chromium is 3d5. The ionization energy is less as compared to other elements. On moving left to right, size decreases and nuclear charge increase. Let us talk about energy gap. Energy gap between Ns and N-1d electrons is less. -1d electrons is less. Both 3d and 4s electrons can participate in bonding. S electrons shift in d electrons because of small energy gap. Now we will discuss about reorganization of energies. Higher number of unpaired electrons, higher number of energy exchanges. See the example of d orbitals. 3d 5 configuration. 5 electrons are filled. This is half filled configuration. This electron can exchange its energy with these orbitals in second, third, fourth and fifth. If we count the total exchanges are 10. Now see the example of a chromium positive ion. The configuration is 3d5. The second ionization energy of chromium is high because after loss of one electron it gets stable configuration, and the stable configuration is half filled. So it is difficult to remove one electron. We need large amount of energy to remove this electron. So the second ionization energy of chromium is high. Now see the case of copper. The configuration of copper is 3d10 4s1. In case of copper, see the case of copper. The configuration of copper is 3d10 4s1. In case of copper, after losing one electron, it gets stable. The stable configuration is 3d10. This is stable and fully filled configuration. First ionization energy is low because less energy is needed to remove this electron. So the ionization energy is low. But the second ionization energy of copper is high because the copper has configuration after losing one electron is 3d10. This is very difficult to remove the electron from 3d10 configuration because this is stable and large amount of energy is required. So if we need large amount of energy to remove electron, then our ionization energy is high. So copper has a second ionization energy is high. The d block elements offer poor shielding effect. The effective nuclear charge increase because they offer poor shielding effect. Charge increases, then ionization energy also increase and interelectronic repulsion also increase. At last, see the case of manganese. The configuration of manganese is 3d5 4s2. This is half filled, and if we remove these two electrons, it gets stable and half filled configuration. The third ionization and see the case of manganese. The configuration of manganese is 3d5 4s2. This is half filled, and if we remove these two electrons, it gets stable and half filled configuration. The third ionization energy of manganese is very high. After removal of two electrons, it gets stable configuration and large amount of energy is required for removal of electron. This is very important topic in ionization energies. The manganese need high energy for third ionization energies. After removal, this is half filled and stable. So it is very difficult to remove this electron. Large amount of energy is required. That's why the third ionization energy is very high. Thanks.